In this video, we will discuss how to display a satellite image as a true color composite and a false color composite. A true color composite is an image that represents a scene as it would appear to the human eye. In our daily life, a true color photo is created by combining three specific bands called red, green, and blue. There are a total of 11 spectral bands in Landsat 9. These are grayscale images that has recorded the energy of different wavelengths of electromagnetic radiations coming from Earth. Bands include coastal aerosol band, blue band, green band, red band, NIR band, shortwave infrared band 1, shortwave infrared band 2, panchromatic band, cirrus band, thermal band 1, and thermal band 2. By displaying the blue, green, and red bands through the channels of blue, green, and red colors and combining them, a true color representation of the terrain is created. For example, if we look closer, the vegetation will appear in its actual color. In False Color Composite, we use these three color channels to display other bands also. By using the same display channels, we can visualize other bands also. This will help us to see the information from wavelengths that are invisible to the human eye. For example, here we will use the green, red, and NIR bands to display a false color composite. Since the NIR spectrum is not visible to the human eye, we will assign the red channel to the NIR band and the green and blue channels to the red and green bands, respectively. These bands are then combined to form the false color composite. In this false color composite, areas with high reflection of the NIR spectrum will appear red. For example, the red areas in the image represent vegetation. Since healthy vegetation reflects more in the NIR spectrum, the assigned red color will highlight cropped as well as forested areas. Let's explore how to display true color and false color composites in Google Earth Engine. To begin, we will open the Google Earth Engine code editor. In the code editor, you can zoom to the area of interest. Then place a marker on the interested location. The details of the geometry entered will appear in the import section. First of all, we shall declare a variable called L9Image and assign all the Landsat 9 image collection to that. A detailed explanation of how to display a Landsat 9 image is provided in a previous video on this channel. The steps are clearly explained in the video titled Google Earth Engine 3 Basics, Displaying Landsat 9 Raw Images. Now we will continue with the code to display TCC and FCC. Filter the image using the date range first. Then using geometry, we can further filter the images for the area of interest. Here, the order of applying filters can be your choice. Then, the images with less than 10% cloud is filtered for the chosen location. Next, the best image is selected from the filtered images using cloud cover as the sorting parameter. From the sorted images, the first image is finally selected. Now, the variable L9Image contains a single image with minimal cloud cover captured over the area of interest. We can display the image using the map add layer command with L9Image as the argument. This will display a black and white image of the area. To get the true color composite, we need to specify the bands for the display. For true color B4, that is red, B3 green, and B2 blue are specified. We can specify a range of digital number values for a better display. To know more about the digital number concept, you may watch this video in this channel. We can give a name to the layer display as TCC. Click Run to display the true color image. The only change needed in the code to display the false color composite is to adjust the band combinations to B5, the NIR band, B4, the red band, and B3, the green band. Additionally, we can rename the layer as FCC. Running the code will display both the True Color Composite, TCC, and False Color Composite, FCC, in separate layers. The available layers can be managed in the map window. Different false color composites, FCC, can be created using various band combinations, depending on the type of analysis you intend to perform.